Head of the department, Dr. Manoj Dubey sir, all the faculty members and all the students present here. I, Vaishali Dhote, take this opportunity to welcome our guest of honor, Dr. Ram Jaane Chaudhary sir, for rendering your precious time. A plant symbolizes the knowledge and village. Wisdom, the knowledge which eradicates darkness from the world. With these thoughts in mind, we would like to honor our esteemed guest with the token of appreciation. So I request Dr. Manoj Dubey sir to felicitate our guest with a sapling as a token of our gratitude.
स्टेज पे आ जाइए. Before beginning with today's first session, let me first introduce our today's guest. It is an honor to introduce such an honorable guest, Dr. Ram Jaane Chaudhary sir. Sir has completed his PhD from University of Pune in 2005 in joint collaboration with University of Maryland College, Park, USA, and Inter-University Accelerator Center, New Delhi, India, on growth and properties of functional magnetic oxides and their irradiation studies. Sir has been faculty research assistant in the University of Maryland College Park, Maryland, USA, from 2002 to 2003. Not only this, Sir has been Embark Fellow in Physics Department, Trinity College, Dublin 2, Ireland, from 2005 to 2006. And currently, Sir is Scientist G in UGC DAE Consortium for Scientific Research, Indore. Sir has guided 10 PhD students. And speaking about awards, Sir has been awarded with DAE Young Scientist Award in 2013 and DAE Group of Achievement Awards in 2017. Sir has published more than 350 research papers in international journals. Apart from his outstanding scientific contribution, Sir is very well known for his humble nature and down-to-earth personality. Now, I request Sir to begin with his lecture.
Thank you. Namaskar, good morning. And thanks to Dr. Manoj and Dr. Kavita, Dr. Nisha for inviting me here to talk something about my own take on the technologies, its requirement as on today, the challenges, what are the avenues, what are the possibilities, and in what way actually we have to go and what we are doing in that context. So, can I go to my slides, please? Yeah. So, we know that as on today, everything that we can think of, all those things mostly depend on the technologies. What are technologies? The technologies are those devices through which we can control certain parameters, certain features. For instance, we have mobiles or the simplest we can think of is pen, right? Even pen is a simple technology that we always carry in our pocket. So what it does, it just utilizes the property of surface tension, and then you use your hands to translate or to write or to express your thoughts either by means of words, letters, images, pictures, you know. So technology to me is a kind of control that we like to have. This mic allows me to speak in my own normal mode, but still it allows you to listen to those who are even sitting in the last row, right? I do not have to shout. So in that way, this technology is helping me to transfer express my own ideas even to the person who is sitting quite far away from me, right? So the title of my talk accordingly is Awareness of Trends and Technology. That was the title that I was given. So what does it do? So it changes this slide. Okay. And does it have a pointer? No. Okay. No problem. Yeah. So the title is Awareness of Trends and Technology. I have just slightly tweaked it. What is nature's perspective? What can we learn from nature? So that is the whole message. And then finally I will show you that how those knowledges that we are gaining from the knowledge, we can actually translate in terms of devices, okay? So I come from this UGC DAE Consortium for Scientific Research, which is like 7 kilometers away from here near Bhavar Square, and I urge you all to visit one day at least and look into the facilities, the experimental facilities which are available there, mostly for research purpose. And there we do research on materials science. We work on wide range of materials. We look into their structural property, optical property, magnetic property, electrical property, spectroscopic properties, all the different properties that one can think of, thermal properties, all those properties can be measured at these places, okay? So if you happen to do research or any faculty present in this audience wishes to use these facilities, they just visit our web page and see that what are the facilities available, and you write to us. Please remember, there is no cost involved in using these facilities. So here is the list of facilities which are available for preparation of samples. When I say that we have to prepare sample, so that essentially means if I have some material and its optical property I have to measure, it's not that just I take this remote and take it to the lab and say that, okay, I want its transport property or the thermal property. Every machine has a proper design and the device architecture which allows a particular shape or the form of the sample which can be measured with those techniques, right? So we have to actually design that sample in that particular fashion, okay? So these are different techniques involved, and besides these in-house facilities, you will be glad to know that this city, Indore, has the unique facility in the country which is called as Synchrotron radiation source. Nowhere else you will see in the country, and very few limited countries have this synchrotron facility. And one such facility is at Arcat, Indore, which is like 4 kilometers away from here. So this Arcat synchrotron facility, what is synchrotron beam? You have a very high moving electrons with relativistically high speed in nature, and then because of that relativistically high speed electron, when they are forced to change the direction, remember electrons are the charged particle, and if I have to change its direction, what I have to do? I have to apply magnetic field, right? So if those relativistically high speed moving electrons are forced to change their direction, what it does? You are trying to accelerate them, and because of that acceleration, the charged particle emits EM radiation. But the advantage is that since these electrons are very high speed moving electrons, Therefore, the radiation that they are generating, they are coming in a very high brilliance and high focused and highly directional, okay? So this beamline, this synchrotron radiation source is available here in Indore, and using this synchrotron radiation source, again, one can do a wide range of studies, be it structural study or magnetic studies, and probing those materials. So these are the beam lines. Again, for using these facilities, one doesn't have to worry about the cost. Now, these are the facilities which are available at these places. That is just for your information. Now, coming to the main theme of the talk, that what are the technologies and the trends and the things that we can learn from nature. So the plan of my talk is like, why do we need them? How do we get them? And what are the parameters which actually control those particular properties? Now, if you just look at this nature, anything that we are seeing present in the nature from our naked eyes without using any technology. Now, you will certainly appreciate one thing, that all these natural phenomena that we are seeing, they have come to this stage by, self-evolving process, self-competing process. Through the ages of crores of years, right? And in that process, the nature has established certain techniques, certain tricks of its own to tackle certain issues, right? And because of that, for instance, if you just look at the birds, the way they fly, they have very beautiful wings, and through that wings, they can control the aerodynamics, and through which they can maneuver their direction of motion, right? You can simply look at the butterfly. You can simply look at the fishes, the way they just move into the water, right? So just by understanding their dynamics, that what are their skin structure that allows them to flow so easily in this, viscous medium. So can we learn something from them, right? What are these plants? For instance, if you just look at the lotus plant, you will see that the lotus leaves do not allow the water droplets to stay on its surface, right? Water droplets simply flows away. So they produce a, hydrophobicity. Hydrophobicity means it doesn't allow that water droplets to stay on surface. Why does it happen? And then there was research in that context. You just look at the lizard, the way they move, they can easily climb on any wall, vertically up, right? Why can't we do that? Can I learn something from them? And if I can learn something from them, then one can do, we have seen a Spider-Man, and we can mimic those concepts and the dresses to follow those particular actions, right? If you just look at, for instance, I will show you in that context that there are certain features that all these creatures have developed to sustain, survive in this competing scenario. Because they have to always be worried about their enemies, their, the hunters. So in that way, they have developed their tricks to survive in this competing world. Can I also learn from them to have those tricks, mimic those structures in the laboratories, and can come out with a certain new type of devices, right? So, to me, I have said earlier that nature is all about the self-evolution, self-sustainable, self-progressive. Whereas, if you look at the human's behavior, it's mostly relying on the control of the things. We do not like things to happen the way it is happening. We always try to control things, right? So the controlling phenomena is somewhat conflicting in terms of nature's nature, which allows it to grow, in a self-organized fashion. So these are the competing scenarios. Therefore, in temperament as well as in the character, there is a kind of conflict between the nature and the human. So one has to really come to an optimized situation where we just appreciate the presence of each other and can learn something from the nature to enhance the betterment of our life, okay? So if I just, look at our own perspective, the very first question that I asked myself, that what is the time when a human being, when comes into the existence, how does it interact with the nature inherently without any guidance of their parents? So my answer was that possibly the new baby born is sensing the light. So the light is the very first interaction with the human being when it comes into the earth or into the existence, to have an interaction with the electromagnetic radiation, right? Now, if you look at this electromagnetic radiation wavelength range, it compasses a huge range of energy, whereas the visible range is only a fraction of it, right? So it is in the range of, say, some 360 nanometer to 740 nanometer or so, right? Only that much window we are allowing to see ourselves from this naked eyes, right? And through which we can make a distinction, okay, there is a green, blue, red, etc., all those things, right? So, and even in this visible range of light, wide range of properties that we have learned. It has reflection, it has refraction, it has diffraction, it has polarization, all those optical properties that we can think of, right? So, if you just look at this particular current scenario, I can see you. Why? Because the light present here allows me to get that light irradiated on your face, and that light is reflected to my eyes, and my eyes have my own sensor, and it transfers that signal to my mind, and then I make a picture of you, right? And through which I get a sense that you are present here, right? Now, how does this light work in a normal way? The easiest example is that you have an atom, electrons surrounding around the nucleus, revolving around the nucleus. You give some energy to that electron goes into the excited mode. After staying for some time, it again relaxes back. And when I say relaxes back, that means it comes back to the ground state. And during that process, it emits a radiation. And that radiation is nothing but the light, okay? So, this particular emission is nothing but a spontaneous emission, right? So, most of these bulbs that we are seeing around us, they rely on this spontaneous emission of radiation, right? But when we understood that how this spontaneous emission works, as I said that humans want to control, we had agreed to do better. Can I learn this technique to do it in a better, to have another degree of freedom which will allow me to have a better emission in terms of light, in terms of emission, in terms of brightness, in terms of intensity, in terms of its coherency, in terms of its focus. So from there, when we understood that how this light is generated, we came with an idea. When I say we, that means the human beings, okay? We came with an idea, okay, you excite an atom, and when it is in the excited state, you shine another photon with the same energy. So that what it will do, it will allow that excited electron to emit in a coherent way, and through which you will have a stimulated emission of radiation, and through which you can amplify the emission of the light which was coming out. And from there, we learned the technique of laser. And we know today that what lasers can do, right? So that is what we did. We understood from the nature what is a spontaneous emission, and from understanding that a spontaneous emission process, we learned how to make lasers, okay? Another example that you all may be very fond of, because all these mobile gadgets, internets, data storage, speed, etc., most of these things work on the optical fibers, the way that, the methodology, the mechanism through which this optical fiber generally works on. So, on what simple physics it works? We know that light has a property of refraction, right? What is refraction? When light travels from one medium to another medium, there is change in density. Because of the change in density, the speed of the light in these two mediums are different. Therefore, they deviate from their original path. Okay? So, by understanding this, refraction process, we came across total internal refraction. What is total internal refraction? When your incident angle is greater than a particular value, critical value, then that light is not refracted, rather it is undergoing total internal reflection. By understanding this refraction process, then total internal reflection process, scientists came out with the idea of optical fibers. So in that optical fiber, I mean that you can also do in your house. What you need is just a bottle of, I mean a water bottle, you puncture it with a very small pin, and then you shine a laser light at the point where that water is actually flowing out. You will see that when there was no puncture, there was no water leaking from that bottle, the light from the laser actually travels in a straight path. वो सीधे रास्ते से जा रहा है. लेकिन जहां से पानी गिर रहा है, जैसे आपने उसको पंक्चर किया, तो और वहां से अगर आप लेजर लाइट डालो, that water molecule does not allow that laser light to simply go straight. It forces that laser light to undergo successive internal reflection. So water in this particular case does not follow a straight path, rather it follows the path of the water flow. Okay? Just by simply understanding this simple trick of, total internal refraction, the scientists came out with the idea of fiber optics. They coated these optics with such kind of materials which allow that incident light to undergo successive total internal reflection, and through miles and miles away, they are just transferring all these signals. Okay? Now, I talked about the lizard structure. You look at this particular gecko. I mean, it can easily climb on any wall. So the scientists in Bell Lab, they just wondered about how does it carry that much of weight. And they can, I mean, their equivalent force that they can carry is even 30 kg when they are just going upward on the wall. So they just looked at their leg structure. They found that the leg had very tiny fibrous structures. It was like kind of a spatula. एक छोटे से spoon की तरह उसके पाँव में structure होता. Now, when these leg structures are coming in contact with the wall, what they found that the kind of force that is acting between the wall and the leg is that of Wonderwall Force. और उस वंडरवॉल फोर्स के कारण वो जो है अपने लेग को स्टिक करके रखती है, एंड देन इट हैज ए सर्टेन मैन्यूअर स्ट्रक्चर थ्रू व्हिच दे कैन जस्ट चेंज देयर पोजीशंस वेरी क्विकली. ओके, सो जस्ट बाय मॉनिटरिंग दीज स्ट्रक्चर्स, बाय द वे व्हाट इज वंडरवॉल फोर्स? वंडरवॉल फोर्सेस आर डिफरेंट फ्रॉम केमिकल बॉन्ड्स. आयनिक बॉन्ड या कोवेलेंट बॉन्ड की तरह नहीं होता है. वंडरवॉल फोर्स is like, even in those, they act between the molecules that act because your positive charge center and the negative charge center present in the molecule or the, gases that you are thinking of, those charge centers have slightly different positions. And because of that, you have certain polarization. Polarization means certain electric field. Okay, and because of that electric field, there is a certain force acting between those two individual mediums. Okay, so they created this kind of structure in the laboratory. Okay, this kind of a spatula structure, and they just rearranged all of them together on a single platform. And then they found that can they also create that kind of effect that the lizards generally show. And here is the boy who actually worked on this particular experiment. They created all these hand gloves with so many spikes, so many spatula structure. And you can see that this is not a cartoon as such. This is a real picture, and the boy was just hanging. Okay, so that kind of experiment can be done just by understanding that how these lizards actually work. They mimicked that structure in the laboratory, and they came out with this kind of technology and device. Now we know that how does these spider, they create their own cobwebs. वो जो एक जंजाल होता है उनका, ये सारे मकड़ियों का. Remember, these webs are very, very light, but they are much stronger than steel. Okay? They can even capture, एक बार सांप भी उस जाल में फंस जाए तो it's very difficult for that snake to even come out from that web. Okay? So it is so strong. This is what I'm trying to say. Now just imagine with that light character, so I mean it's very, very light, right? But at the same time, it is one of the highest strength kind of species present with us. Okay? So they thought of to have these cobwebs with huge amount, and then by creating that kind of cobwebs, they can create a wide range of devices. But to create any device, you needed a much higher amount of such cobwebs. But they found that these cobwebs are nothing but some kind of protein coming out from that silk that these spiders generally generate. But these spiders do not like a cooperation. They do not like society as such. They always try to eat each other. They kill each other. So there is always a competition between them. Therefore, to create so many cobwebs in higher amount was a rather challenging task. But then scientists found that the silk gland through which it was creating that kind of protein from that spider, similar gland is present in the milk gland of lambs. So what they tried to do, they injected that kind of what should I say, the gene from that spider web into that lamb, so as to enhance that productivity of cobweb coming from the milk of that lamb. And they injected, and they were actually successful that they could enhance so many cobwebs. So in that context also the research is going on. This particular lamb was used for this experiment. Okay? Now you just look at the butterfly. The beautiful butterfly, when it just lifts off from the flower where it is actually staying. So it has a multiple character, that it can have a vertical takeoff, then it can easily move in the horizontal direction. So it has a maneuver of vertical motion as well as horizontal motion. How is it possible? Just imagine that if there is some war going on between India and Pakistan at the borders, we know that Himalayan borders do not have that much of plain area where the aeroplanes will easily take off or land, right? But if we design such aeroplanes which allow us to have a vertical takeoff and then have this horizontal motion, then we can have a much better control over all these properties. I'm just giving one such extreme example. I wish that no such war happens. But just let me tell you the advantages of having so many controls over the motion of all these aerodynamics. Okay? So in that context, what they found, they just looked at the motion through which their wings were actually flapping. And how did they do that? They allowed that butterfly to go through a kind of a smoke house. And just by looking into the dynamics of a smoke through which those, the way those smokes are actually changing its position, they actually monitored every bit of motion of the butterfly wings. And by mimicking that kind of a structure and controlling that kind of motion, they had this kind of robo-fly just by looking into that, how these wings are actually changing its position. And from there, they created this kind of structure. You can see that this is a real mosquito at right side. This is the lab-created mosquito, which was able to just take a vertical up or horizontal motion. Or you must have seen in that movie Uri, where there was one robotic fly which allowed the maneuver and the control over all these things. So this is what we are actually learning from the nature, and in order to create certain devices. Okay, you look at this cuttlefish. The cuttlefish is important in the sense that it can survive by this camouflage technique. What is camouflage? वो अपने आप को इस परिदृश्य से एकदम से गायब कर देता है. कैसे गायब करता है? it has, tiny fluid bags with 3 color pigments under its skin. So the moment it sees that there is some threat coming to it, it just changes its color to suit its surroundings, so that there is no easy distinction between the cuttlefish and the background, as if it doesn't exist. Okay, I mean, that is just like Mr. India, who was simply invisible, right? So that kind of tricks that people found that cuttlefish was having. Okay, and when the background didn't have those 3 individual colors, then it has, it has some kind of deeper skin scales with which it covers itself, and through that scales it just reflects that light. So whatever light is coming on that particular scale, it is reflected. Therefore that reflected light carries the same color which is present in its background, and that is how it protects itself, right? So those tricks again people are using. This is another example of this beetle. The advantage of this, the peculiarity of this beetle is that if you just look at, it lays its egg only on those trees which are half burnt, not completely live tree, not completely burnt tree, rather half burnt tree. Why does it do so? It does so because, if it lays its egg on the live tree, then the secretions coming from the tree will be dangerous for the eggs that it is laying. So it will kill those eggs. And these beetles are quite smart in that way. Okay? And if it lays its egg on a completely dry tree, then it will not, those eggs will not have food for growth. Okay? Therefore, they needed a half burnt tree. And that is why nature created an infrared sensor in its structure so as to detect that some tree is burning few miles away, and there it goes and then it lays its egg. So just by looking into that, how these infrared sensors work, what kind of infrared sensor is present there, यहाँ पर हमारे यहाँ किसी भी इंस्टीट्यूट में या किसी भी ऑफिस में आप देखेंगे कि गैस सेंसर्स लगे होते हैं, फायर सेंसर्स लगे होते हैं. किस टेक्निक पे काम करते हैं? Whenever there is change in temperature, whenever there is change in the local gaseous surroundings, some of the properties of that material changes, right? जैसे टेम्परेचर हुआ अपने को, तो हम थर्मामीटर लगाते हैं. थर्मामीटर लगा करके पुराने समय में जो मरकरी का लेवल है, उस मरकरी के लेवल को ट्रैक करते थे कि कितना आया है. Why? Because with temperature हम लोग जानते हैं that there is change in the pressure और वॉल्यूम. जो चार्ल्स लॉ है या बॉयल्स लॉ है, उसको सिंपल से फॉलो करके, राइट? सो with the change in the surrounding situation, that surrounding situation can be pressure, it can be temperature, it can be gases, some of the properties of the material will certainly change, right? For instance, if you just take a semiconductor and you increase the temperature, what will happen to the resistance? Any comment? कोई बता सकता है? किसी सेमीकंडक्टर का टेम्परेचर हमने बढ़ाया तो उसका रेजिस्टेंस कम होगा या ज्यादा होगा? कम होगा. कितने लोग कम वाले हैं और ज्यादा वाले कितने हैं? ओके, या सर्टेनली कम होगा. क्यों? क्योंकि टेम्परेचर बढ़ाने पे पहली बात तो सेमीकंडक्टर में क्या होता है, फ्री इलेक्ट्रॉन्स होते ही नहीं है. चूंकि फ्री इलेक्ट्रॉन्स नहीं होते हैं तो उसमें फ्री इलेक्ट्रॉन्स कैरियर वाला जो इक्वेशन है वो उसमें वैलिड होना ही नहीं है. ठीक है, तो फिर करंट कैसे फ्लो होगा? करंट इसलिए फ्लो होगा क्योंकि जैसे ही किसी भी टेम्परेचर पे जो आपके इलेक्ट्रॉन्स वैलेंस बैंड में है उनको थर्मल एनर्जी मिलता है तो वो कंडक्शन बैंड में जाते हैं, और जब वो कंडक्शन बैंड में जाते हैं तब जाकर के आपको करंट मिलता है. ठीक है, तो जैसे जैसे आप टेम्परेचर बढ़ाएंगे तो नंबर ऑफ इलेक्ट्रॉन्स गेटिंग एक्साइटेड फ्रॉम द वैलेंस बैंड टू कंडक्शन बैंड, they will keep on increasing and hence your resistivity will decrease. Higher the number of carriers, lower will be the resistance. मेटल के केस में उल्टा होता है, right? In case of metals, you increase the temperature, resistance increases. Why? Their resistance increases because if you increase the temperature, because of that temperature, because of the thermal energy, there is lattice vibration. Your atoms move from its mean position more than its normal conditions, right? And because of that motion, the free electrons which were traveling, they encounter more number of scatterings. Higher is the scattering. Higher scattering means higher resistance value, right? That is why metals and semiconductors are different in their character as far as resistance is concerned when we vary the temperature, right? बस इतनी सी बात है. Why I gave this example is because just to let you, feel that how properties of materials depend on their surroundings. Okay? Here I have taken a simplest example of temperature. So just by varying temperature, we dealt with two different materials. Their response was different because their structure is different. Their electronic arrangement is different, right? So this is important. Okay. So similarly, this infrared sensor works just by observing that there is some tiny change in temperature. Some of the properties present in that bit as a sensor, that changes and that transfers the signal to the mind, and that is how it just locates its position where to lay its egg. Now, you look at the fish. People have found that fish has antibiotics in its glands, and just by looking into its feasibility and its versatility, कितने अच्छे से अपने आप को survive करता है, they created that kind of antibiotics and they are working more into it for our health care. Now, if you look at the shark motion, such a bulky fish, but it moves very fast with a very less drag. Drag means जो उसको एक frictional force create करता है उस water motion में, तो वो बहुत कम है. तो what they found, they looked into the structure of its skin of the shark, and they found that they had a particular shape, and through that shape it allowed that water molecules or the water streams just to pass through easily, and they created that kind of structure, and they coated this structure on aeroplanes to see whether they can decrease the petrol cost or not, or the fuel cost or not, right? Because the required fuel arises because of the air drag, right? So if I can mimic that kind of a structure, indeed this was the aeroplane which was used to coat that kind of a structure, and they certainly found that, okay, the air drag was considerably lower than the normal condition. So this is what we can learn. This is the water droplets on the lotus plant here. Our group also worked a bit on it, and there they found that why lotus did not allow that water droplets to stay on its surface, because they looked at the very micro images of the lotus leaf structure, and they found that this hydrophobicity arises because of a particular pattern on its leaf structure. And if I can create such leaf structure in the laboratories by using some artificial material, can I also get this hydrophobicity? The answer was indeed, we also did that. And importantly, we can also change its hydrophobic nature as well as hydrophilic nature simultaneously just by shining light on and off. यानी कि हमने laboratory में एक artificial structure create किया titanium oxide का, और with similar structure which was found to be hydrophilic. वो कैसे पता चलेगा? उसके लिए सिंपल सा एग्जाम्पल एक्सपेरिमेंट जो कर सकते हैं, एक वाटर ड्रॉप आप डाल के देखो. अगर वो वाटर ड्रॉप आसानी से फैल गया, इसका मतलब वो हाइड्रोफिलिक है, और अगर वो नहीं फैला, वो एकदम सर्कुलर या स्फेरिकल मोड में ही रहा, so that means it is hydrophobic. So just by looking at the contact angle is the angle its surface makes with the substrate, the material on top of which that water molecule has been placed, right? So we did that kind of experiment, and we found that the grown structure created that hydrophobic nature, but importantly जैसे ही उसके ऊपर लाइट डालते हैं वो हाइड्रोफिलिक हो जाता है, लाइट ऑफ कर दो हाइड्रोफोबिक हो जाता है. So that means you are creating an optical control of this hydrophobic or hydrophilic nature. So that gives us a remote control of certain properties, and it has so many applications. अच्छा, हाइड्रोफोबिक का यूज सबसे सिंपलेस्ट जो आप लोग सोच सकते हो, जो अपने किसी भी बिल्डिंग के जो आजकल जो नए बिल्डिंग्स बन रहे हैं, it has a glass window, right? On all those glass windows you can see that whenever there is some rain taking place, तो कुछ ना कुछ coating हो जाता है, some dust particles remain staying there, right? So if your windows are coated with that kind of hydrophobic structure, it will not allow those water molecules to stay, and your window will remain ever clean. Okay, so those are the examples. Now, I mean, this is what we can, I have just given a few examples that we can learn from the nature, and how do we recreate them in our laboratories. So you can see that this is what we are doing by learning from this nature. We have I mean, changes almost in all the industries, be it aerodynamics, be it petroleum industry, be it our own James Bond, be it our own computer. You remember James Bond from the Sean Connery days. He had a very bulky car, this kind of. And now today you see Daniel Craig having very fantastic car with so many automated motion. So when I say so many automated motions, so many automated actions, that means a single device is acting in a multi-purpose way. It can allow you to, to act like a fire sensor. It can allow you to act like a gas sensor. It can allow you to even fire the animations and all that, right? So how is it possible? This is all possible because you can co-locate the sensors, the actuators, the computers, the control, the communication, all these different phenomena together on a single platform. That we call as micro electromechanical systems. So on a single device, you will have this microphone, actuator, structural material, data storage, antenna, transmission and all that, okay? So, and how is it possible to co-locate all these different properties together on a single platform? Because today the thin film technology has allowed us to integrate those materials having different properties together on a single platform, okay? Now, how one can create those devices? So you choose a particular material with certain applications. For instance, if you have to deposit some insulating materials, some insulators. Why you need insulators? Because of some capacitor effect. Let us say, take for example, okay? So you deposit that material, then you transfer that pattern, then there is removal of material. You make a, underlying sections, usko etch out karte ho, फिर individual sections को निकालते हो. Then you check the properties of individual dyes, and then finally you transfer it into some kind of pattern. So it is very important to actually know that which technique I should follow to prepare that kind of materials, thin films and the device architecture. So you will see that these thin films work in wide range of applications, be it anti-reflection coatings, moisture sensors, data storage devices, gas sensors, PN junction, photovoltaic devices and things of that nature. And there are, see, we want different applications. Can one material work for all these different applications? The answer is certainly not. I just gave you simplest example of semiconductor and metal. There are insulators, there are magnetic materials, there are non-magnetic materials, there are thermally conducting materials, there are thermally insulating materials, wide range of materials. There are optically transparent materials, there are optically opaque materials. So all these materials have their different properties and hence their different applications. So to prepare a particular device, you have to know that which material I should choose for this particular device application. And when you choose that material, then which technique I should choose to grow or prepare that kind of material, right? So accordingly, you must have a very vivid idea of which materials are used for what type of applications. So these are just some of those applications for, gas sensors, tin oxide, titanium oxides, or for data storage, DMS, and etc. are there. Okay. Now, which techniques I should use to grow thin films? There are two techniques which are broadly categorized. One is physical vapor deposition and another is chemical vapor deposition. The name tells us, in physical vapor deposition, is the physical method to get the vaporization done for the deposition to take place. Whereas in chemical vapor deposition, it's the chemical reaction taking place at the surface of the substrate, right? What is substrate? Substrate is the material on top of which we are preparing the film, okay? Now, what is the easiest way of vaporizing the material physically? Can you tell me? सबसे आसान तरीका फिजिकल मेथड किसी भी मटेरियल को वेपोराइज करने का बताएंगे? हाँ जी? Sorry, someone said something. Heating the material, right? Heating करने से होगा क्या? When you heat the material, you are giving thermal energy to the material. थर्मल एनर्जी से क्या होगा? वो जो एटम्स हैं अपने पोजीशन से इधर उधर वाइब्रेट करेंगे. अभी भी कोई भी सॉलिड इस सॉलिड फेज में क्यों है? It is present in the solid phase because there is some kind of bonding between the atoms, and that bonding keeps the atoms close to each other. That is why they are solid. But when your thermal vibration crosses a particular limit, तो फिर ये एटम जो है इस एटम को नहीं जानता, मैं नहीं जानता तुझे, तो ये एटम बोलता है तू नहीं जानता तो मैं चल पड़ा, and it just ejects out from the material. This is evaporation. So what evaporation does? You provide the thermal energy beyond a particular value that the atomic vibration overcomes the bond energy for evaporation to take place. And when that evaporation comes out, then you collect those evaporants on top of substrate. बचपन में जब हम पढ़ते थे दिए में, तो दिया से वो लॉ निकलता था, उसके ऊपर आप पेपर रख दो, थोड़ी देर के बाद आप देखोगे कि एक कार्बन की कोटिंग तैयार हो जाती है, फिल्म तैयार हो जाती है. That is also a simplest example of evaporation that you can just assume that way. Okay, so there are different. Now what thermal vibration does? It transfers energy to overcome the bond energy through thermal vibration. अब प्रश्न उठता है, क्या हीटिंग ही एक तरीका है जिसके द्वारा हम एनर्जी ट्रांसफर कर रहे हैं मटेरियल को? द आंसर इज नो. आई मीन देयर आर सो मेनी वेज ऑफ ट्रांसफरिंग एनर्जी. किसी को क्रोध आता है, वो अपने हाथ का जो पोटेंशियल एनर्जी है किसी के चेहरे पे ट्रांसफर कर देता है. दैट इज अनदर वे ऑफ ट्रांसफरिंग एनर्जी, राइट? सिमिलरली हियर यू बम्बार्ड द इलेक्ट्रॉन बीम्स ऑन द टारगेट. तो इलेक्ट्रॉन ने क्या किया? अपनी काइनेटिक एनर्जी उस टारगेट को ट्रांसफर कर दिया टू ओवरकम द बॉन्ड एनर्जी, एंड देन इवेपोरेशन टेक्स प्लेस. यू बम्बार्ड विद द लेजर बीम. Laser transfers its energy to the target to overcome the barrier, and hence evaporation takes place, right? So there are so many techniques through electron beam, through energetic ions, through laser. So different techniques of transferring energy means different techniques of preparation of thin films, okay? So if we are using electron beam, this is called as electron beam evaporation. If we are using ion beam, that is called as ion beam sputtering. If we are using laser beam, that is called as pulse laser deposition. Why do we need all these techniques? The answer lies, one particular technique is not good for all types of material. So for understanding, we have to really know that what are their advantages or what are their disadvantages, okay? Now if you look at this electron beam evaporation और थर्मल इवेपोरेशन, दोनों जो है इवेपोरेशन प्रोसेस पे काम करते हैं. तो वहां जो रेट ऑफ इवेपोरेशन है, जब वो इवेपोरेंट स्टेट में आता है, तो वो सिंपल सा जो गैस काइनेटिक इक्वेशन है ना, चार्ल्स का और वो बॉयल्स का जो कंबाइन करके PV = nRT, उस सिंपल इक्वेशन को फॉलो करते हुए जो रेट ऑफ इवेपोरेशन है, आप देखोगे कि वो जो मास ऑफ द कंस्टिट्यूएंट एलिमेंट है उसके ऊपर डिपेंड करता है. ठीक है? अब मान लो तुम्हारे पास कोई कंपाउंड है, किसी एक कंपाउंड का नाम आप लोग ले सकते हो, एलिमेंट का नहीं, कंपाउंड का, किसी भी एक कंपाउंड का. हाँ जी, कैल्शियम ऑक्साइड, फैंटास्टिक, ओके, कैल्शियम ऑक्साइड इज वन. ओके, थोड़ा सा मैं और एक्सटेंड करता हूं, कैल्शियम मैंगनीज ऑक्साइड, ठीक है, कैल्शियम टाइटेनियम ऑक्साइड, बेरियम टाइटेनियम ऑक्साइड, wide range of materials, right? So you will see that when you have more than one element present in your composition, तो उनका जो evaporation rate है different element का, वो अलग अलग होगा, because the constituent element has different masses, right? Now, since their masses are different, therefore their evaporation rate is different. So if I have to prepare a film of say BaTiO3 और CaTiO3, तो कैल्शियम अलग इवेपोरेशन रेट से निकल रहा है, टाइटेनियम अलग रेट से निकल रहा है, ऑक्सीजन अलग रेट से निकल रहा है. So when they reach at the substrate, they are not in the same chemical composition which was present earlier in your compound, right? So the whole purpose of making that device of CaTiO3 will be lost, because in your film you will not have CaTiO3, rather it will be Ca.9, Ti.7, oxygen 2.5, anything non-stoichiometric. What is stoichiometric? Stoichiometric is chemical composition present in the material. So there will be compromise on the stoichiometry, right? So this is good for growing iron film, copper film, titanium film, calcium film, all those things, but not for a compound which has more than one elements present in the composition. Similarly, sputtering, we know sputtering में क्या होता है, energetic ions आया, अपनी सारी energy जो है transfer कर दिया target material को. अब जहाँ कहीं भी टक्कर होती है, collision आता है, तो collision का equation class 7-8 में हम लोग पढ़ते थे, conservation of energy, conservation of momentum. Now again in this conservation of energy or momentum, you will see that mass is again involved. So again sputtering yield, yeah, the number of elements will be ejected from the target that will be different from your original composition, right? So again this sputtering is limited for particular class of material. Now comes PLD, pulsed laser deposition. इसमें होता क्या है कि अपना जो लेजर बीम है वो पल्स्ड फॉर्म में आ रहा है, ठीक है? अब मान लो एक लेजर बीम ऑफ ड्यूरेशन 20 नैनोसेकंड और एक लेजर बीम की जो एनर्जी है 200 मिलीजूल है. सो 200 मिलीजूल एनर्जी इज बीइंग ट्रांसफर्ड इन 20 नैनोसेकंड. हाउ मच पावर इट इज जनरेटिंग? पावर कैसे डिफाइन करते हैं? एनर्जी डिलीवर्ड पर यूनिट टाइम, ठीक है? 200 मिलीजूल डिवाइडेड बाय 20 नैनोसेकंड, दैट इज लाइक 10 मेगावाट. With that high power, when that laser beam bangs on the target, वो खलबली मच जाती है सारे एटम्स के बीच में. जो सारे एटम्स हैं immediately eject होते हैं. Local temperature few thousand degree centigrade pico second में change हो जाता है. And because of that, all the constituent elements present in that particular target, which is falling in the vicinity of that laser beam, all of them are simultaneously ejected. वहाँ जो है बेरियम को ये कहने का मौका नहीं मिलता, नो नो नो, आई हैव डिफरेंट मास सो आई विल कम एट डिफरेंट इवेपोरेशन रेट. नथिंग डूइंग. लेजर बीम कम्स, bang on the target and simply takes away all the constituent elements present in the target material, and that is how it preserves the stoichiometry. ठीक है? तो that is, I mean, I am just giving a few examples that why we need different techniques to grow different types of materials. तो हुआ क्या कि ये सारे के सारे इवेपोरेंट्स निकल गए और कहाँ पहुँच गए? सबस्ट्रेट के ऊपर. अब सबस्ट्रेट के ऊपर वो कैसे रीअरेंज हो रहे हैं? पहला इवेपोरेंट आया सबस्ट्रेट पर, फिर दूसरा इवेपोरेंट आया सबस्ट्रेट पर. अब सबस्ट्रेट तो बहुत बड़ा है, इवेपोरेंट तो आपका एंगस्ट्रॉम लेवल पे है, तो एक एटम कहीं गिरा, दूसरा इवेपोरेंट कहीं गिरा, तीसरा इवेपोरेंट कहीं गिरा. वो बेचारे कब तक वहाँ टहलेंगे? You just imagine the very first day when you joined this college. The first thing, what did you do? You tried to locate yourself. Where is your classroom? Where is the office? Who will be the teachers? What are the syllabuses? And all those things. So what you did, you tried to get accustomed to the local surroundings. This is called as coming into the equilibrium. ठीक है? आप इक्विलिब्रियम में आ गए. उसके बाद आपने क्या किया? आपने सोचा क्या मैं ही अकेला हूं जिसने इस कोर्स को ज्वाइन किया है, और there is someone else also. So you started looking for your friends. जब दूसरा बंदा मिल गया या बंदी मिल गई तो आप दोनों साथ घूमने लगे, तब तक जब तक कि तीसरा ना मिले, चौथा ना मिले, पांचवा ना मिले. दैट इज हाउ यू फॉर्म्ड योर ओन ग्रुप. लेकिन जरूरी नहीं है कि सारे बच्चे आपके ही ग्रुप में आए. कोई दूसरा XYZ है जो अपना ग्रुप बना रहा होगा या बना रही होगी, राइट? एंड दैट इज हाउ दिस होल क्लासरूम इज फॉर्म्ड, right? So exactly these evaporants also follow a similar phenomena. First evaporant comes, second evaporant comes. The first thing that they do is to get into the thermal equilibrium with the surrounding. After obtaining the thermal equilibrium, they hop onto the substrate surface from one side to another side, unless and until it finds the second evaporant, third evaporant, fourth evaporant, and that is how this nucleation takes place. कहीं और भी न्यूक्लिएशन हो रहा होगा, और जैसे जैसे ये न्यूक्लिएशन साइज बढ़ता है तो कहीं ना कहीं आपके दो इंडिविजुअल ग्रुप में कोई एक स्टूडेंट ऐसा होगा जो दो ग्रुप के बीच में एक ब्रिज का काम करता है, जो दोनों ग्रुप में होंगे, राइट. सिमिलरली these nucleation sites come close to each other to give rise to a complete film. Here is the picture. Because of this light you may not be able to see this very explicitly, but I hope you got what I'm trying to say. Okay, so using these structures one can get different kinds of, okay, so this is what I was saying. The atoms come, they have surface diffusion, then there is nucleation, and when those individual nucleation comes close to each other, they have agglomeration and hence a larger thin film growth structure taking place. And you can see, you can create a beautiful or wide range of patterns on the substrate surface just by patterning the substrate on a particular structures. Now, जो हम लोग क्लासरूम्स में पढ़ते हैं, IV कैरेक्टरिस्टिक, PN जंक्शन डायोड, नॉन लीनियर IV, तो ये सब जो है, you can create all these things in laboratories by creating this P type of material grown on N type of material, right? Okay, you can also create this photovoltaic cells. You shine the light, because of that shining the light, the electrons or the holes are ejected, and if those electrons or holes, they create current, and one can use the sunlight to, for energy harvesting. One last example that I will take up, because we are talking about the upcoming devices, there is a lot of discussion about spintronic devices. नाम पे मत जाना, जब ज़्यादा ना समझ में आए तो हिंदी में हम लोग संधि विच्छेद करते थे, कोई भी बड़े शब्द को दो पार्ट में ब्रेक करो और फिर समझ लो. Spintronics, spin based electronics, right? So we know that electrons have three intrinsic properties: charge, spin and mass. अगर आप PN जंक्शन डायोड या इस तरह के किसी भी प्रॉपर्टीज, ट्रांजिस्टर वगैरह के प्रॉपर्टीज को देखोगे ना, they mostly rely on the mass and the charge nature of the carriers. They do not generally exploit the spin character of electrons, right? But if one can capture the spin property of electron, one can come out with wide range of fascinating devices which is called as spintronic devices. And the advantage of those spintronic devices will have, like, I will just give you that example. You will have a decreased electric power consumption, realization of quantum bits, increased integration densities compared with conventional semiconductor devices. आप लोग जो आजकल देख रहे हो कि वो जो पेन ड्राइव की कैपेसिटी बढ़ती जा रही है, thanks to development in all these spintronic devices, because spintronic devices allow a very efficient control of the electron motion present in the devices. Okay, with these examples, I think I will conclude my discussion for the day. That technologies, of course, is a part of reality in our life. Our lives mostly rely on how efficiently we can control these technologies, or it allows us to control certain phenomena in our life. But at the same time, please remember, we should not be the slave of these technology. We should use these technologies for the goodwill, for the goodness, for the betterment of our life and support of our society. With these words, I will conclude my presentation. Thank you all for your patient listening.
Sir, you can continue. You can continue. If somebody has any query, you can go ahead.
And I request that can our students go IUC for visit IUC for.
They all are welcome. Please come to IUC and see the facilities which are available there. Yeah.
So they perform the project and.
Sure.
So what are the process?
Process is that you take a bus, you come there, and we will show you the laboratories. You just let us know in advance that we are coming, and we will request our scientists and students to help you out and spare some time for you, and you will separate the students groups in tens of them, and then we'll show them around. There are liquid nitrogen plant, liquid helium plant, wide range of facilities. You will see that it's unique in the country in many, many senses that you will enjoy after reaching over there. Yeah.
So 10 students can come there?
Yeah, certainly. This is mostly for PhD students, but even these younger people who have recently joined, and if they are willing to see that जो टेक्स्ट बुक में जो वो पढ़ते हैं IV characteristic और spintronic और magnets और synchrotron, all these things they can see for themselves, and then they will really enjoy seeing them. Yeah.
Thank you very much.
Yeah. Questions from you? आप में से किसी का कोई प्रश्न? नहीं तो फिर मैं पूछूंगा. Okay, thank you for not asking. Thanks a lot.
Thank you so much, sir, for your empowering words. For all the students, your next session will be held in the same Audi. Please gather here around 12:45.